I just wanted to, I've talked about storage before, and I just wanted to talk about it in sort of managing storage in relation to costs. Sort of like right now in the 2I2C Jupyter Hub that NASA Openscapes is providing, but also sort of like the thoughts and different structures that you'll encounter as you sort of move into other cloud platforms. So hopefully it's a little bit generalizable. I just wanted to note too that I think it was Liz earlier mentioned about us turning off access. So everyone in the Champions cohorts will continue to have access to the hub for a year. So it's a great place to sort of work on playing and testing out strategies for working in the cloud. And we are working on, I think there was some discussion already this morning, sort of pathways to other sort of like more permanent infrastructure for like big science projects. So yeah, that's kind of the context. We were so this is kind of a Luis's talk is actually kind of a good segue here, where you're sort of in some right now. We're going to talk about working in the cloud, even though Luis wasn't. So you're working in the cloud in an EC2 compute instance. So that's like the machine that's doing the processing for you, and you're going to be sort of downloading, or even better, streaming and subsetting and filtering data from the NASA Earth Data Cloud to work on. And at some point, you're probably going to want to store that data. And there's a few places where you can put things when you're working in the hub. And one is the home drive, which is kind of the natural place to put things. And then the other ones are these scratch buckets that we've talked about before. And really what I want to say here is that like the home drive is a great place to store code and small things. It's persistent across sessions, so you can continue working on your code, but it's not a great place to store data because it's expensive for it. But S3 is a great place to store data, especially for big data and for a long time because it's cheap. And just to note that like a cost for compute is like really variable, because depending on the amount of processes you're doing, the size of the machine that you're using in the cloud, it's really gonna vary the cost. Storage is kind of not totally, but kind of a fixed price for as long as you store that thing. And so thinking about those ongoing costs for storage is important. And I just want to point you back to this how-to that we walked through in the call 3 for sort of ways to use these S3 buckets for storing data. Policy, everyone loves to talk about policy. It's really exciting. This is still under development, and so as you are interacting with these things, if you have any feedback for how they're set up, or any thoughts about policies, then we're happy to chat about it. Basically, we want you to store code in your home directory and store data in those S3 buckets. We're going to be archiving home directories after 6 months of inactivity. And we actually archive it to a different S3 bucket. And if you sort of come back and you see that your home directory has been wiped out, you can get it back from us. So that's easy enough for us to restore. And however, after that archive has been sitting for another 6 months, then that will also get removed. So just sort of policies around like how long you can keep things. Right now, we don't have a policy for your sort of individual S3 buckets, especially for the persistent one. And so we're sort of still thinking about how long to keep those around. But it's the home directories that we're really trying to manage the storage in. And really the sort of guiding principle here is keep the amount of data that you're storing in your home directory small. And we will definitely help you if you need it. The policies are kind of written out in more more detail at this URL here, if you want to read about it. And just like a little peek behind the curtain there on sort of how we're monitoring and looking at storage in the home directories. So these home directories are stored in EFS, which is Elastic File System, and it can get expensive. And so this is sort of the NASA Openscapes Hub total size of storage across all users' home directories. And you can see it's like kind of steadily grown. There was a massive spike at the beginning of March. It was actually before I had joined, so I don't know what led to that. But if we stayed at that level, we'd be sort of spending $1,200 a month on the static storage, and that would be ongoing unless we sort of take measures to clean it out. And sort of this sort of nice big downward slope here was us working with users and developing policies to move unnecessary data out of that home drive storage. Just to note here, we use a system called Grafana for monitoring these things. And that's where this data is being pulled from. So here is yours. This is the home directory usage of the 2024 champions. Each color here is a different user. This is when we sort of gave everybody access. So obviously there's just like a minimal amount in there. And a couple of users got like pretty excited and started using them, which is excellent. Like we definitely want people using this infrastructure. But you can see that home drive storage can really balloon, sort of, up around 150 gigabytes. And then we sort of started again to work with users to use that storage a bit more efficiently, and we've brought it back down. So yeah, just a little peek into how that storage can grow and shrink in the home drive. And then sort of translating that back directly to costs. Here, blue is the cost of the compute, so that's EC2. And you can see it's really variable, and it goes up and down with like directly how people are using that compute infrastructure. So people are in there running models, using that, and that's really going to go up and down. However, you can see that like the storage costs are fixed, right? Because that data is just sort of sitting, and it gets charged for sitting at rest, and so the red is the storage cost in basically users' home directories. So this is sort of like $15 a day with that, and so we've brought it back down to around $5 a day currently. You can barely see it, but these little green bars on top are S3 costs, and so that's the cost of using those buckets. And most of those costs are actually the cost of moving data in and out of them, rather than the actual storage costs. The storage costs are so small right now that it's not even showing up as a daily cost. And so the sort of take-home message here is that like if we can move that storage, because we haven't actually deleted data from what was in these home directories, we've just moved it into S3, but massively reduce the cost. And so I guess the point here is that like if we can defer the cost or remove the cost from storing data because we're just doing it inefficiently, we've got way more resources to actually do science. And I think that's what we really want to promote. We can put that cost to using the compute that we want to do our science with, rather than storing huge amounts of data that incurs ongoing costs.